Now, let's have a look at some of the problems related to permutation. And as I said, in the permutation, the order is important. So let's try to find out whether in the given problem we have that kind of notion, the notion of order. Now, how many ways are there to select a first prize winner, a second prize winner, and a third prize winner from 100 different people who have entered a contest? So there's a competition or contest going on, and we have to look at the ways we can have the first prize winner, a second prize winner, and the third prize winner. So as it's quite clear from this, like implicitly you get the idea of order, because we have the first prize winner, we have the second prize winner, and the third prize winner. So therefore, this is the problem of the permutation, and we have to find the number of permutations here. Therefore, we know in this case n is 100 and r is 3, because this is 1, 2, and 3 prizes. And secondly, in this case, no repetition is allowed, because you cannot be the first prize winner and the second prize winner and the third prize winner at the same time. So the idea of no repetition being allowed here is will be clear if you make the distinction. Let's say if we had to find all those 3-digit length strings, if the only choice we have is from 0 to 9, and we have to see how many of these are possible, 3-digit, a string of length 3 are possible. So we will have 10 choices here, 10 choices here, and 10 choices here. So in that case, repetition was allowed. Like you can even have 1 here, 1 here, and 1 here. Or you can have 2 here, 2 here, or 2 here. So repetition was allowed. But in this case, it won't be allowed, because you cannot be 3, 2, 1, or the first prize winner, second prize winner, and the third prize winner at the same time. So what we'll have here is this will look like 100 P3, so which is equal to 100 factorial divided by 100 minus 3 factorial, which is equal to 100 factorial by 97 factorial. This will be 100 times 99 times 98 times 97 factorial divided by 97 factorial. So this and this will cancel out. What you will get is 970,200. So these are the number of permutations that you will get if 100 people are participating and we have to choose 3 prizes. Now, suppose a saleswoman has to visit 8 different cities. She must begin her trip in a specified city, but she can visit the other 7 cities in any order she wishes. How many possible orders can the saleswoman use when visiting these cities? So, in this case, she must begin her trip in a specified city. So this one will be fixed. You cannot change anything about it. So out of the 8 cities, let's say this is one city that's fixed, and the second part is other 7 cities. So in total, these are 8 cities. So here, she can choose any order. So she can arbitrarily fix any order and then proceed forward. So out of all these 8 cities, you cannot do anything about this. But what you can do here is you can fix an order, and secondly, this is again an example where no repetition is allowed. Therefore, what we'll get is it's as if we are only focusing on these 7 series. So we'll have a permutation expression which is like 7p7. So that will be equal to 7 factorial divided by 7 minus 7 factorial, which is equal to 7 factorial by 0 factorial. And you will get is 7 times 6 times 5 times 4 times 3 times 2 times 1, because 0 factorial is equal to 1. So the number of possible orders that a saleswoman can have while visiting these teas is equal to, if you calculate this number, this will be equal to 5040. Now let's have a look at another example. How many permutations of letter A, B, C, D, E, F, G, H contain the string ABC? Now, the thing worth noting here is that this will be fixed. ABC will be fixed. So whatever permutation you get of these letters, A, B, C should be intact. So if you get a, for example, this one is one of these permutations, A, B, C, D, E, F, G, H, let's say is one. And similarly, let's say D, A, B, C, E, F, G, H is another, but this is still intact there. This is fixed. Then let's say another is like this, D, E, A, B, C, F, G, H. So in all of these, this was fixed there. Like you will see them, the ABC intact there. But if you look at this example, let's say A, then we have E, then we have B, C, F, G, H. This will be a wrong permutation. This is not what we are looking for, because these are separated from each other. All we want is that A, B, C should remain fixed. So in that case, what we'll do is we'll consider A, B, C to be as a single entity. So all we are left with is D, E, F, G, H. So this remains fixed. So we'll consider this to be as one entity. And these are 1, 2, 3, 4, 5. These are 5 letters. So in total we have 6. So in this case, N will be equal to 6 and R will be equal to 6. Since order matters here, and secondly, no repetition is allowed, therefore, what we'll get is 6 factorial divided by 6 minus 6 factorial, which is equal to 6 factorial, because this is 0 factorial and 0 factorial is equal to 1. 6 factorial by 1. So that will be equal to 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. So these many permutations of the letters A, B, C, D, E, F, G, H contain the string ABC. So that was these were some of the problems related to now in next videos I will be discussing the concept of combination and how combinations are different than permutation.